Advancements in graphics hardware now allow full screen effects to be performed on a rendered image to create a wide variety of special effects. When used properly, post-processing effects can give a cinematic quality to computer graphics. Leadwerks Engine features a low-level buffer and shader system which allows rendering of any kind of post-processing effect. Although this requires a deeper understanding of shaders than a simple turn bloom on system, it allows far greater flexibility. New post-processing effects can be added without having to modify the engine source code. To render post-processing effects, we're going to use an additional buffer. We'll first render the scene to the gbuffer, then render lighting onto the postbuffer. In the last step, we'll draw the postbuffer color texture onto the back buffer with post-processing effects applied, as shown in the diagram. The first two effects we discuss will only use draw settings, while more advanced effects will use a postfilter shader. We're going to start with this simple program which just loads a scene and renders it. And we're going to create a gbuffer. Then we're going to create a postbuffer. And down here, first we set the buffer to the gbuffer. We render the background, and then we render the main world. Then we're going to set the buffer to the postbuffer and render lights from the gbuffer to the postbuffer. And then finally we draw the postbuffer color texture on screen, and that's where we can apply our special effects. So you can see it's just rendering a sky and it's rendering the scene like normal. But if we add some code here, we can change things. I can change the drawing color. And that will colorize the final image. I can also perform a simple motion blur effect by enabling a blend mode when I draw this. So I'm going to say set blend, blend alpha, and then I'm going to set the color, and I'm going to use a value less than 1 for the alpha. So I'll say set color vec4 1 1 and then 0.5. So this will enable alpha blending, and then it will draw the postbuffer color texture on screen. And this produces a simple motion blur. Because it's drawing the image on screen and it's blending it with what was drawn the last frame, and then the next frame gets blended on top of that, and so on. If I change this alpha value to 0.1, it will make a stronger blur. There's a really, really heavy motion blur. And if I changed it to a higher value, it wouldn't be so strong. Now we can also enable a shader during this last image render, and that's how we get our really neat effects. So up here before the main loop, I'm going to load a shader. I'll call this postfilter. and I'll load the desaturation pixel shader. And then down here, I'll just say set shader, post filter. And now let's see what that does. Now we have a black and white image being rendered. Now before we go any further, I want to show you how the post filter shaders are laid out. I've got the shaders extracted to a folder here, and then I'll go in the post filters folder. And if we open up, let's see, post filter underscore desaturate, you can see that it defines this LW desaturate value, and then it includes the main post filter pixel shader. And then if we look at the main post filter pixel shader, we can see all these different effects are built into it, and then it just includes different files based on what values have been defined. So here it says if LW desaturate has been defined, then we'll include desaturate.frag. Okay, let's go there. Here's desaturate.frag, and we can see that it's changing the value of this output color variable. So just like the mesh shaders, all the pixel shaders for the all the post filter pixel shaders are in one main file, and that includes different files. And then if you want to use a different effect, you load one of these files that has the defines, and then they all include the main post filter pixel shader. Distance fog is another effect that we can perform, and it's a post-processing effect. So I'll just load the post filter distance fog pixel shader. But there's one thing different. The distance fog needs a depth texture to read from. So if we go in here, we see all these texture uniforms declared, and it says what they're used for. Texture 0 is the color, and texture 1 is the depth. Texture 2 is the normal. We don't need to worry about this because this effect isn't going to be using the normal buffer or any of these other things. But we do need to make sure that the depth buffer is bound to texture unit 1 when we render this effect. And we can do that with the bind texture command. And I'm going to say get depth buffer, and I'm going to get the depth buffer of the gbuffer, which is the first buffer that we render to. The other ones don't have depth buffers because they don't need them. And I'm going to bind it to texture unit 1. And then I'm going to draw the image on screen.